So is my slide visible on your screen? Hello.
Yes, sir. Yes, sir. Yes, sir.
Okay, thank you. So this is first session of day one. Not first session, third session of day one. So unfortunately, the session of second session we could not conduct due to non-availability of Professor uh, Chukumar Misra, who is Professor of Department of Engineering and IIT Delhi. So in this session, we have with us Professor D.L. Vinod Kumar, who is a professor HAG, Kennedy Warrington. So on behalf of organizing committee, let me welcome you in the Faculty Development Program SCI 2021, organized by the Department of Electrical Engineering and National Institute of Technology, Durgapur, and it is sponsored by the ACT Atal Training and Learning Academy. So, Professor DM Vinod Kumar, he has joined at NIT Warangal. Previously, it was Regional Engineering College Warangal in the year of 1980. So he was head of Department of Engineering in 2007 to 2009. He was deputy chief warden at hostels or chairman library president. So he was chairman of Institution of Engineers India, Warangal local chapter during 2012-14. At present, he is a professor HAG of Electrical Engineering Department at National. He obtained his BE in Electric Power System Engineering from Osman University, Hyderabad during 1970. So he obtained his PhD degree from IIT Kanpur in the year of 1996. The title of his PhD thesis was Artificial Neural Network Based Power System State Estimation, and he has obtained the uh, degree in the year of, yes, from the IIT Kanpur. And during 2002 to 2003, he was postdoctoral fellow at uh, uh,
and I zero e to the power minus r by into t. And it is
Monik sir, you are not audible.
similarly here. What is
Yes, please wait. Due to power shutdown suddenly, this circumstances. Please, all of you, please wait.
So extremely sorry, I've been disconnected due to power cut. Uh, so Professor B.M. Vinod Kumar, during 2002 and 2003, he was postdoctoral fellow at Howard University, Washington D.C., USA. So he was the principal investigator for the R&D project entitled Real-Time Control of Power System during using fuzzy neural network during 1999 to 2001, sponsored by MHRT New Delhi. Uh, So the grant was about 5 lakhs. Another R&D project entitled Fuzzy Neural Network based automatic generation control was funded by College Research Grant NIT Warrangal during 1996 to 1998. So both these projects are completed at present. He is a principal investigator for the R&D project sanctioned by Institute of Engineers Kolkata entitled Intelligent Transmission Management in Power System Deregulation Environment. So he has published more than 110 papers in international journals and conferences. So he organized two-day national seminar on fuzzy logic and neural network applications in electrical engineering in September 1999, and organized one-day national workshop on neural network and fuzzy logic application in electrical engineering in 1999. So he organized two short-term courses, training programs of 2 week duration in 2008 and 2009. A 3-day workshop on power control and energy management was organized by Professor uh, Kumar during 9 to 11 May 2013. So he was a convener for the National System Conference in the year 2016. He organized a gun program on wide area monitoring and control of cyber physical system in the year 2017. So he supervised nine PhD scholars, and at present he is guiding three PhD candidates, supervised undergraduate and postgraduate project also. He is a fellow of I India, Kolkata, and life member of SSI. He's a member of Board of Studies of Department of Electrical Engineering, Osman University, Hyderabad, and JNTU, Hyderabad, Kakinada, and Anandpur. And he is a member of doctoral committee at Vellore Institute of Technology, Vellore. He reviewed two books published in Tata McGraw Hill, New Delhi on neural networks. He delivered expert lecture on neural networks and fuzzy logic at various institutions. So his research area includes power system optimization and control system stability, neural network, deep learning, machine learning, and fuzzy logic applications, flexibility transmission, power system deregulation, restructuring, and smart grid technologies, and multi-objective evolutionary algorithm applications and renewable energy system. So now I request Professor uh, uh, Kumar to share his screen and share his expertise in this field with all of us. So he will be delivered. Will be will, his topic of lecture is AI applications in electrical engineering. So now I request Professor Vinod Kumar to
Okay.
share his screen. Please.
Good afternoon, everyone. First of all, I wish to thank Dr. Baumik and his authorities for giving me this opportunity. And after having lunch, and have this somewhat difficult to concentrate, but I will try to make it somewhat interesting. And as on today, the buzzword is what we will talk, the artificial intelligence, or we'll talk about machine learning, and we will use the words like data science, okay, and machine learning, several things. Therefore, all of the, whether you talk about either neural network or deep learning or machine learning, anything, the important thing is that the training as well as testing we will call in case of the neural network, whereas in case of the machine learning and all that people will call training as well as the prediction, predicting something. It is clear, Bhumik, what I'm speaking?
Yes, sir.
Yes, sir. Yes,
Okay,
sir.
okay, thank you. So in this one, uh, the basis for this one to start, either you start as a neural network or machine learning or anything, the data is required. That's why people are talking as in today, data science also. So in this one, the training, you want to, training or learning, both are same, we require some data. Okay, therefore training and learning both are same. And in neural network, we will use the word, our buzzwords, training and testing. Whereas in case of the machine learning, our buzzwords are training as usual. And instead of testing, we will use the word prediction. And one more thing, the general words we will use in any AI, we will use the word learning techniques. There are three different of the learning techniques will be there. One is the supervised learning, another one is unsupervised learning, another one is the reinforcement learning. If you know, if you understood these things, our life is more comfortable with respect to this AI. And one more thing is that what I will say, this artificial intelligence techniques to understand is very simple. Unless we are having some practice, we will do anything with our own hands. Okay, you can use any software or toolboxes, anything. But if you do how it is working with our own hands, then it is more can understand how the network is working, etc., and all that. And one more thing, come back to this neural network. Okay, in this one, the thing is that we will require that is training and testing. The training means what happens is that you will acquire the knowledge. Okay, acquire the knowledge, and after acquiring the knowledge, how it will acquire the knowledge based upon some learning methods. What is the learning methods? I will talk about. And after acquiring the knowledge, then we will make use of the knowledge for a particular situation. Just like a student, whereas learning is suppose electrical or mechanical or computer science, whatever it may be, 4 years he will learn subject knowledge, and after that he will make use of when he's doing a job or somewhere he can make use of his knowledge, whatever knowledge is acquired. And one more thing, you can interrupt anytime in between, okay? And I can also ask if anyone knows some questions, you can answer those things. And most of the time, these things we will call knowledge-based systems because knowledge is stored in case of neural network somewhere in terms of some weights. Okay, in the fuzzy logic also knowledge is stored in terms of some rule-based, etc. Knowledge and wisdom both are same or both are different? Knowledge and wisdom. Okay, both are different. Okay, the knowledge is that we can there is one proverb is there. What is the proverb? A person can acquire knowledge with other person's knowledge, but a person cannot be wise with other person's wisdom. Okay, most of the time I will say the wisdom is nothing but common sense. Therefore, in this one, as in today, this major success of this AI, autonomous cars, that self-driving cars. Most of the time, you might have seen, as in today, some of the cars, some NG, Aster, the car, they're using some of the features of the self-driving cars, self-cruise control, suppose self-braking. Okay, that is when anything is coming, suddenly obstacle is there, automatically it will brake. Some of the features they are introducing. Therefore, to have this self-driving cars or autonomous cars, we require intelligence, like human-like intelligence is required. Therefore, we require certain machine learning algorithms, okay, as well as the reasoning also, automated reasoning. If we include both together, it will act as a human intelligence. Because just machine learning will not sufficient for a driverless car. For example, if you see, we have trained the network with a stop, you want to stop somewhere. So if someone has removed on the board, P has removed, STO is only is there, then we should be able to understand. Therefore, a reasoning is also required. The reasoning is nothing but once again, it is a common sense. And once again, these AI people are using in playing chess and automatic translator and speaking in English, it can be converted into different languages. And one more thing is that this, with respect to the people are talking, what is that machine learning? It is nothing but statistics. If you are good in statistics, okay, machine learning is nothing but almost all the algorithms we are borrowed from the statistics only. Therefore, in this one, this machine learning or data science, okay. Therefore, and one more thing is the machine learning point of view requires some probability, statistics, and knowledge with respect to whatever whether you are using in power systems or power electronics or somewhere wherever you're using. The domain knowledge is also required, and data corresponding data is also required. And this artificial intelligence, we are classifying, as I mentioned, artificial neural network, deep learning, fuzzy logic, machine learning, several things. Therefore, when you're using this computational intelligence, that is the study of adaptive mechanisms to enable to facilitate intelligent, that is, you want to take decision making based upon the data, you want some decision, that quick decision you have to take. Therefore, intelligent behavior in complex and changing environments based on mathematical models of biological systems. Whereas in case of this neural network, what we are doing, we are mimicking the human brain, whereas in case of the fuzzy logic, we are mimicking the human mind. Okay. Therefore, in this one, we are using several words like artificial intelligence, that is any technique that enables computers to mimic human behavior. And machine learning, as I mentioned, is entirely, it is a statistics point of view. We know the statistics as a probability, etc. Therefore, ability to learn without explicitly being programmed. That means without explicitly programmed means, if you see, for example, a computer is there. What is the input to the computer? Data and program. Corresponding, I write a program, let us say, I want to convert from a degree centigrade to Fahrenheit. There is a formula is there to convert degree centigrade to Fahrenheit. Then I write a program in C or C++ or Java, whatever it may be. Therefore, to the computer, I will give data corresponding program I will give. What is the output? I will get some output. That is, if you have written the program, degree Fahrenheit to centigrade you want to convert, therefore, I will get the output corresponding to the given Fahrenheit to centigrade. Whereas in case of machine learning, what happens is that you will use input as a data as well as the output. Okay. And what is the output I will get? Program. Program means it is not like a C, C++ and all that. I will get a model. That means here, this in the machine learning, the basic difference is that in the machine learning, what we will do is that suppose we are having suppose you are having equation, let us say y equal to f of x equation is there, whereas x is the input and whereas y is the output. Then what is this f? In the machine learning, we will determine this f, modeling. This function we will model. Therefore, the function can be a linear function, or a function can be non-linear, or a function can be polynomial, a function can be logistic, whatever it may be. Classification problem the problem can be regression or classification. Therefore, in the machine learning, in a nutshell, what I want to say is that we will determine the model. Model means either linear or non-linear model, etc. That is where it differs. In case of the neural network, the training and testing will come into picture. Whereas in case of the machine learning, training is same. In case of testing, we will use prediction. The model is the linear model. The model can be like A0 plus A1x. Linear. It is like a y equal to mx plus c. Straight line model. Therefore, I should determine from the data A0 as well as the A1, I will determine. Then when you are given the x, I will get the y. Therefore, this is the function what you will do in the machine learning algorithms. Therefore, with respect to this machine learning, that is whatever the output we are getting, it is not a program. Whatever we are seeing, we are just to program we are getting, because based upon this here data and output is a program. Strictly speaking, it is a model. We will develop the model. It is a linear or non-linear model. Whereas in case of the deep learning, okay, it is the basic difference between the a neural network and deep learning is that As in today, whatever we are talking about this neural network, we are calling it the shallow neural networks, shallow neural network, or people are calling conventional neural network. Whereas in case of this deep learning, the deep learning, because the neural network will have the input layer, hidden layer, the output layer. Whereas in case of the deep learning, once again we will have the out of this, as I mentioned, three different of the learning methods are there: supervised learning, unsupervised learning, as well as reinforcement learning. The convolution neural network that is we are using, it is supervised learning. Therefore, in this one, the basic difference compared with the backpropagation algorithm, one of the algorithm in the neural network, is that it will extract features. The deep learning, it will extract the features. And one more thing in this deep learning, the input is the image. The input is some image. The image will convert into some pixels. Like the input is like a matrix will be there in the deep learning. Whereas in case of the neural network, that is shallow neural network or conventional neural network, the input is a vector. Then with the preamble to this AI, man has learned much from studies of natural systems using what has been learned to develop new algorithmic models to solve complex problems. The basic questions what I will pose is that generally whenever using any new this AI, in particular neural network, what is the need? But if the need is that I want to reduce the computational time, suppose I want to solve a set of nonlinear algebraic equations by using a numerical technique like a Newton-Raphson method or Gauss method or Gauss-Seidel method. Suppose it's taking 5 minutes or 10 minutes, let's say, based upon the complexity. Suppose I want to reduce my computational time in milliseconds or microseconds or nanoseconds, then it is better to use the neural network, the best candidate. Therefore, this AI is a machine emulation of human thinking process. Therefore, when I'm talking about the machine, AI is the machine emulation of human thinking process. It is like a fuzzy logic. In case of the fuzzy logic, what we will do is that we will mimic the mind. Suppose if you see in just nutshell, the role of the ANN, artificial neural network, is the brain. Our natural neural network is that our brain. In the brain, we will have the billions of neurons will be there. Therefore, our role model is the brain in case of ANN. Whereas in case of fuzzy logic, the fuzzy logic, father of the fuzzy logic is the ZA. What it says, working with words. In the fuzzy logic, everything we will talk about in terms of words. Therefore, just a thinking process. Suppose a student has got two jobs. One job he got in Infosys, another job he got in TCS. Let's say both are software companies. Therefore, which is the best? Therefore, if you don't know anything with respect to Infosys, what is opportunities and all that, you will go to a person who is working in Infosys, you will get the knowledge of the Infosys. You will go to the in TCS, if you don't know anything, you will go and ask a person who is working in TCS how the opportunities will be. Then based upon this one, he is having in his hand two jobs are there. He will think in his brain, in his mind, which is the best, whether in TCS is the best or Infosys is the best. Finally, he will take a decision. Therefore, everything is in terms of words. Therefore, our role model is we will take mind as a fuzzy logic. And one more thing will come into picture: evolution algorithm. Most of the time, this evolution algorithm we will use for optimization techniques. Therefore, in this evolution algorithm, if you see the second point, evolution computing began by lifting ideas from biological evolution theory into computer science and continues to look into biological research findings for inspiration. Most of the time, this biological or evolution computing EC, we will use that is PSO algorithm. We are making the birds, how they are moving and all that in a group. ABC, bee colony, artificial bee colony, and bees, how they are working and all. Ant colony, ants, how they are working. Therefore, we are mimicking in case of this in this evolution computing. Whereas in this evolution is evolution means improving from one generation to another generation. Some improvement is required. Therefore, in the optimization problems also we should improve from one iteration to another iteration. It should be much better. It should be. Therefore, evolution is an optimization process where the aim is to improve the ability of individuals to survive. Therefore, this evolutionary computing is the emulation of the process of natural selection in search process. Therefore, optimization technique itself, it is a search process. From that, I want to pick the best one. Therefore, there are several algorithms are there that collective behavior of the collective behavior emerges from group of social insects like birds, ants, bees, bacterial foraging, immunization system, etc. Therefore, when talking about several things with respect to intelligent system or artificial intelligence, what we are calling, what is intelligence actually? Therefore, First, the literature, what it says, social behavior increases the ability of an individual to adapt. Therefore, there is the adaptability as well as intelligence. There is a lot of interconnection is there. What literature says, the person who is interacting with several people, social behavior is more, interacting with several people, you will get a lot of information. When his information is more, that person has become more intelligent. Suppose in the class, a CR is interacting with 59 students in the class. In the class, 60 students are there. Is interacting almost all the students. Therefore, you will get information from each and every student. Is intelligence is more. Suppose students who are become three groups, or three students become one group. They are interacting with only these three. Their information is very less. Therefore, most of the time, what one more literature says, a person is intelligent because based upon adaptability. It indicates, suppose some people will go to a new place, they will not get sleep. They will go to some other place, they cannot able to eat properly. Therefore, some noise. Okay, there is a relationship between adaptability and intelligence. Okay, the person is more adaptable, is more intelligent. And how the intelligence will comes? Intelligence arises from interactions among individuals.
Ujjwal Sur, sir.
Some noise is coming.
Excuse me, sir. Sir, Ujjwal Sur, sir, can you turn off your mic?
Yes, Ujjwal, please mute.
Kindly mute your microphone. Yes, sir, please. Hello, Ujjwal Sur, sir.
Okay, otherwise, can you able to mute others other than me?
Sir, we are trying.
Okay. Okay. Therefore, when you consider the brain, we are considered as a role model. And why you are considered brain as a role model is that it will take less time. Computational life. Whenever I want to reduce the computational time, I should go for the ANN, artificial neural network. In the artificial neural network, they are mimicking the brain. When you are mimicking the brain should have some special things. For example, brain can do wonderful things, several ways. For example, pattern recognition, for example. Pattern recognition is nothing but, as you will know, we have to recognize a pattern. Let us say on this one, I will give a simple episode. Let us say when I'm studying 5th class, my friend is there, one friend. Okay, he is my close friend. He used to sit beside me. His name is Rama. Okay. After 1 year is over, 5th class is over, his father was transferred, he left. But this during 1 year, this Rama is very close to me and used to sit beside me and all that. After completing my BTech, when I went to a place like Bangalore, I see the person like Rama. Still I will doubt because immediately recognize is Rama. Because brain will recognize anything, it stores in the pixels of the brain when you have some interest. When it doesn't have any interest, it will not store anything. That is the beauty of the brain. Therefore, after seeing that person, it looks as Rama. Still, I will doubt. I will go and ask, what is your name? He says that my name is Rama. Immediately, several Ramas will be there. Which 5th class, which school you have studied? He says so and so school. Then it's like that. Then with this episode, what he says that is Rama is my close friend. 5th class, 1 year is my close friend. His features are stored in the pixels of the brain. Therefore, even though other 10 years or more than 10 years, there is no interaction with Rama. I never seen him also, because just by seeing that face, lot of noise is there. His height is changed, weight is changed, several things. Even then, just seeing that his face, I recognize is Rama only. Therefore, it is indicates that we are not using any algorithm or anything just by seeing, because already stored. He is my close friend. I cannot remember all the friends in the class. Only Rama is very my close friend. I able to recognize. That is the beauty of the brain. That is why we want to mimic this, whatever the brain is doing, we want to mimic in the artificial neural networks. Therefore, once again repeating, we can use this ANN whenever we want to reduce the computational time. Now, one more thing, the brain can also act as filter, because most of the time in the house, when I prepare a cup of tea, we'll use a filter to remove the dust, tea dust. Therefore, in the brain also, because some noise is there, it will remove automatically. I will give a simple example. Therefore, most of the time, this filter application as a neural network we will use in computer science, people will use, as well as ECE in electrical engineering also we will use, in state estimation, in image processing, etc., and all that people will use this ANN. Okay, the filter brain will act as a filter. I will give simple example, like suppose I want to travel from Calcutta to Delhi. Therefore, entire day, because I want in Delhi, I want to stay another 5 to 10 days. I want to stay. Therefore, entire day, a lot of work was there for me. Okay, and my train is night at about 12:30. I reached the railway station at about half an hour after, before, by 12 o'clock or just before 12. I reached entire day, and after reaching the railway station, before pandemic, if you see, railway stations are very busy and lot of noise. Okay, so vendors are shouting, and trains, lot of noise, several things. After reaching railway station, there's some announcement, the train which is expected at 12:30, it will reach 1 o'clock, half an hour delay. Therefore, at the time, night 12 o'clock, my body wants some rest. On the platform, I will see some a seat and all that. I will sit for a while. Lot of noise is there, but at the time my body wants some rest. After sitting for a while, then immediately we can sleep for a while, 5 to 10 minutes. Then what is happening? In the house, some noise is there, some control is there. We can ask someone, please don't shout, don't talk, and all that. But on the railway platform, there is no control. We cannot control anyone. Therefore, my body wants rest. Therefore, what brain is doing is that it's filtering all the noise. What is the noise? Vendors are shouting, or train noise, several things are there. It is it will filter in that noise. That is why most of the time the brain, okay, it is used for filtering applications. Okay. Therefore, that is why I give an example in the electrical engineering, state power system, state estimation, and image processing, ECE, etc. One more application, okay, associative memory. This one we will not use in electrical engineering. Most of the time, computer science people will use associative memory. If you know something based on that one, I can remember some other thing. Okay, I will call you for some after some time in the class. Huh? In the associative memory, that is, let us say, I will give one more simple example. I will come to my office, I will do certain work. After that, I want to meet in the campus itself some X, Y, and Z. After that, I will come back to my room. Therefore, after coming to my room, I lost somewhere my key. Then how can I retrieve? Oh, after locking my room, then I went meet X. I will go and ask X whether key is there. No, he says no. I will go to Y. Like that, we will retrieve. Therefore, it is based upon the associative memory. Therefore, certain algorithms are there, or parallels are there on this associative BAM, etc., bidirectional associative memory, etc., and all that. And one more thing, scanner and brain, both are same or both are different. Scanner, if you see, if I keep my photograph, I will get the replica of that photograph I will get. If you keep some text on the scan, it will scan. It may be whatever the language may be. Brain also doing same thing. Scanner, whatever doing, it is temporarily. What is brain? As I mentioned, if you are having some interest, it will store that information in pixels of the brain permanently. Otherwise, and one more thing before proceeding, this scanner and brain. Most of the time, I will go to a movie because a movie, when a movie is released, I will purchase 100 rupees ticket. I will go to movie. After coming out of the theater, sometimes you will get headache. Why will you get headache? I purchase 100 rupees ticket to purchase headache. No one will do, because before going to the movie, my expectations are something. The movie like that, songs will be like the action will be like something. But after watching the movie 2 hours or 2.5 hours, there is a mismatch. My expectations are something and movie is something. Therefore, I will get a day. That is the case. Most of the time, textbooks. When you want to read a textbook, after reading 5, 10 minutes, 15 minutes, then you will get headache. You will keep aside and you will do concentrate on some other thing. But when you are having some interest in novel, I want to read. We will have a target within 24 hours. I want to complete that novel. While eating also they will read. While watching TV also they will read every time. Okay. Therefore, because the target, the interest. Then whenever you have, once again I'm repeating, when you are having the interest, the brain will store in the pixels of the brain. And the last point, brain as a plastic organ. Is brain a plastic organ? No. The plastic, the word which is used, it can mold whatever the shape you want. That is mold. That is, if the plastic is a rectangular shape, I can make it square. Square is there, I can make it a circle. Like that, several shapes that we can change. That is why most of the time if you see in the society, a good person will become bad sometimes. Bad will become good, etc. And all. And one more thing, a student who is good, is a class topper of 10th class, is after plus 2, his performance will become decreases. Sometimes the student performance is average after 10th class, he will become class topper in plus 2. That base everything, how you will program your brain. Your program your brain properly, then it can store everything. You can become a class topper, you can be more successful person you can do. Therefore, that is why the word which is used, the brain act as a plastic organ, is that we can mold whatever the shape we want. That is, every time we have to reprogram our brain, then we can get whatever the thing we can learn or whatever the works we want to do, we can do wonderful way. Therefore, with this brief preamble, this artificial intelligence is the branch of computer science concerned with making computers intelligent. Therefore, the AI is a field of science which concerns itself with designing and developing software that is capable of processing knowledge. Knowledge is processing and applying that knowledge to manipulate an ever-changing situation. That is, these are knowledge-based system, as I mentioned. The knowledge is acquired. After that knowledge is acquired, then we'll make use of wherever it is required. And the human second point, if you see, the human brain is a source of natural intelligence. Okay, because when I'm talking about artificial, we have the natural intelligence, that is our brain, and truly remarkable parallel computer. Then how can you say human brain is a parallel computer? Most of the time you will use a parallel computer whenever it is having more than one processor. As in today we will talk about i5 processor, i7 processor, i9 processor. Okay, like that, only one processor. More than one processor is there, two processor or three, etc. And all we will call a parallel computer. Therefore, similarly with respect to our brain, there are billions of neurons are there. All these neurons are working together. That we are calling as a parallel computer. The third point, if you see, human brain is the most complex machine on earth. The brain did not simply retain a copy of pictures as scanner would, but organize the knowledge on the basis of meaning. Therefore, the brain is fantastically plastic organ, able to constantly reprogram itself to represent and understand the world. Okay. Therefore, in this one, if you see briefly, processor, and if you compare with the von Neumann computer and biological system, the von Neumann computer is nothing but sequential processing of the computer, and the biological system is our brain. Okay, the processor is a complex, is a high speed, and one or few, most of the time our computers will have only one processor. And whereas in case of the biological system, our brain, it is very simple. One biological neuron is very, very low speed. You might have studied in 8th class or 9th class in biology. Okay, the structure of the biological neuron. And a large number, that is, as I mentioned, billions of neurons will be there. Memory, in case of computer, separated from the processor, it is localized. Whereas in case of the brain, okay, the memory is integrated into the processor and distributed throughout the brain. And computing, it is centralized, okay, sequential, step-by-step resolves, and program is stored. Then only can able to do. Whereas in case of the mind, brain, it is a distributed system, it is parallel because all the biological neurons are connected together, and self-learning. As I mentioned, the self-learning or unsupervised learning, then in the learning methods, three different of the learnings are the supervised learning, unsupervised learning, as well as the reinforcement learning. In case of the supervised learning, it is like we will have data point of see x and y will be required, input and corresponding target y. Just like if you want to compute efficiency of the transformer, I require the input as my output of the transformer, iron losses, copper loss. This is the input as a vector. What is the output? You want to calculate efficiency, let us say. Efficiency will give. That is, this labeling is coming to picture. This y, x and y both are required. Input and corresponding target both are required. In case of supervised learning. Whereas in unsupervised learning, there is no supervisor. The supervisor is nothing but it's a guide. For example, in our academics, it may be guide or whatever it may be. So we will call supervisor. Whereas in case of unsupervised learning, only input x is sufficient. Only x will be there. Only there is no correction. Why we are calling supervised learning, input x and y both are there. Suppose BTech students are allotted to a guide, a supervisor y. Therefore, you will go and ask. Students will go to the supervisor and ask the problem, the way in which you are proceeding. The supervisor says, yes, you are going in right direction or wrong direction. Accordingly, you will go on correcting supervisor. Therefore, here in case of unsupervised learning, only input is there is no supervisor. Therefore, most of the time we will use this type of problems for the classification problems. Therefore, based on the problem, we should select some paradigms. So what are the paradigms? I will discuss. Therefore, it is biological neurons, it will learn self-learning by our brain. How it learns? For example, I will give one simple example. What is self-learning or unsupervised learning? Both are same. Suppose if you take in our still in our villages, the remote place, suppose they are cooking on firewood. Okay, there is no gas, stove, etc., and all that. So assuming they are staying in only a single room, and the mother, the lady, she is cooking. She is having a kid of less than 1 year. Then when she is cooking on the firewood on the ground, some blue flames and yellow flames and all that, the kid is fascinated and he want to go and touch the fire. Mother says, "Don't touch the fire; it is harmful to the body." Then while cooking, she will hold the kid because the other will go and touch. One finally, what happens is that once someone has knocked the door, therefore she won't attend. Immediately she left that kid on the ground and she want to attend. Therefore, here what happened is that there is no control. Now the kid will go and touch the fire. Next day, if he keep his fingers near to the fire, he will allow. He says no, he will resist. That is why it is self-learning. Okay. Therefore, most of the time, it is our parents also will say several things, but we will not listen. Okay. There is one proverb is there: who is fool and who is intelligent? The intelligent person is learning from other people's experience. Who is fool is learning with his own experience. Okay, there is basic difference. Okay, operating environment is well defined and well constrained. There is no operating environment itself. The basic difference between the traditional programming, just like you write a program in C or C++, whatever it may be, when you write a program, suppose load flows, you have written the program by using interruption method. I cannot distinguish which is the program, which is not. Both looks the same. Whereas in case of AI based, like ANN or fuzzy logic and all that, then we can show knowledge is different and program is different. After acquiring the knowledge, during training, knowledge is acquired, then program and knowledge both are interact together. Therefore, this is the basic difference between the AI based, that is the AI neural network, as well as the conventional programming. Then if you see the biological, our role model is the brain. We are mimicking our brain in the artificial neural network. Therefore, the fundamental block is the biological neuron. As you will know, the biological neuron will have the nucleus, a cell body, or dendrites. They will act as a receiver. Axon, they will act as a transmitter. And synapse, this is the biological word. What is synapse? Suppose this is a neuron 1, neuron 2 with some interconnection, which is there. We will call this as a synapse. What is synapse with a biology point of view? A functional unit between two neurons. An axon stand of one neuron and dendrite of another. Therefore, receiver, it is transmitting like that. Therefore, put together, this is axon and transmitter, axon and dendrites, we are calling as a synapse. In the neural network, we will call synapse or synaptic weight, etc. We will use the word. Okay. Therefore, the word is from biology, synapse. Now, this is a biology because most of the time for engineering, we cannot do anything with respect to biology. We require some modeling. What do you mean modeling? Modeling means we'll get some equations. When equations are there, I can write the program. Therefore, in the neuron modeling, there are several types of modeling methods. Modelings are there for the neural network. And most of the time, people will use this type of modeling. Suppose if you take this is the neural circle, this is the neuron, and the inputs are x1, x2, xn. Just as I mentioned, suppose you want to that is efficiency of transformer, that is input output of the transformer, iron losses, copper losses. The weights are nothing but small numbers. There are small numbers between, you can generate between plus and minus 0.5 or plus and minus 0.1, etc. Plus and minus, not plus r. Therefore, the weights should be positive also should be required, negative values also required. Some random weight we will generate randomly. Then if we take only up to this point, up to net, if we call, then what happens is that what is the output you will get? X1 W1 plus X2 W2 plus dot dot Xn Wn. If you take only up to this summation, is a linear neuron. Most of the time, the problems are non-linear. If the neuron modeling is linear, then it cannot solve. Therefore, we want to convert this linear neuron into non-linear. Therefore, in this non-linear function, we are introducing, then whatever we are using with the net, we are calling net or net input. Okay, net input to the activation function. Based upon that one, I will get the output. Then whatever the type of non-linear function you are using, I will get the output. output is function of the net. Suppose the function, this f, okay, I can use as a linear activation function. Okay, it will be like a step function. Okay, x input and corresponding output. Okay, threshold is different here. This is some theta is some 0.5. That is up to less than 0.5. All are zeros here. The negative values are all zeros. Here up to 0.5, all zeros. Then only it will become 1. Here we will have the positive and negative values are there. The linear activation function. And we can also have the nonlinear activation function. Most people will use the sigmoidal activation function. The S shape is there, shape is like S, and here the input is the X, output is the f of X. If I use the sigmoidal activation function, this f is the sigmoidal, what output I will get? 1 by 1 plus e to the power of minus x. This is the output I will get. Suppose if you use like tan hyperbolic function, the input is the X, output is the f of X. What is the function? What is this f? This function is 1 by 1 plus e to the power of minus x by 1 plus e to the power of minus x, like that. So if you use Gaussian function, okay, Gaussian, it will have the mean as well as the standard deviation plus sigma as well as the minus sigma standard deviation. Output is e to the power of minus x minus mu whole square by 2 sigma square, like that. And as in today, in the deep learning, people are using a ReLU function. ReLU means rectified linear unit, like rectified linear unit, because if you see this ReLU function, okay, it is up to 0. Okay, there are several variations of ReLU is there. The standard ReLU, I'm talking, rectified linear unit, up to 0, all negative values become 0, and the linearly goes on increasing. Therefore, ReLU is a linear, is not a linear, it is not a non-linear, it is not a linear, it is also non-linear activation function. ReLU is popular because it is simple and fast way to include a non-linearity in our artificial neurons. That is why most of the time when you are using this convolution neural network, people are using, instead of using this sigmoidal activation function or time hyperbolic activation function, they are using ReLU because it will increase the fastness, speed. ReLU performs well and is often the first choice of activation function when building a new network. There are good mathematical reasons for use ReLU. Okay. But the ReLU function, it is nothing but it will give my f of x, which we call maximum of 0 comma x. This is the function expression. Because we require some mathematics, therefore up to negatives are all zeros, and whatever the input is there, suppose your input is 2, my output is also 2. That is your y equal to x. Call this is the x, this is the y, your y equal to x. Okay. That is why people will use. There are several variations of the active ReLU function. It is a standard ReLU. Some people call leaky ReLU and exponential ReLU. Several things people will call this type of different ReLU functions. They come back to this definition of the artificial neural network. Okay, definition, it will give a lot of information. A neural network is a massively parallel distributed processor. People will call, good old days, people used to call this neural network as PDP. PDP, parallel distributed processor, that has a natural property for storing experimental knowledge and making it available for use. It resembles the brain in two respects. First point, knowledge is acquired by the neural network through learning process. The learning is the primary thing in case of any artificial intelligence techniques. And interneuron connection strengths, known as synaptic weights, are used to store the knowledge. Where the knowledge is stored, as I mentioned, if this is the neuron 1, neuron 2, in any connection is that the weights, it will store the knowledge. How it will store the knowledge, we can see. Therefore, this is the, in the neural network, the topology, we are having two types of topologies are there. One is the feed forward, okay, feed forward neural network. Okay, it is like a open loop system in control system. Okay, another one is the feedback, the feed forward neural network, and we will have another one, feedback neural network, or people will call recurrent neural network. In this feed forward, what is happening is that the neurons, okay, it will go, this is the input layer we will call, is the input layer, it is the, we will call input layer, and this is we will call hidden layer, okay, hidden layer is the output layer. Therefore, it is a feed forward neural network. The how many nodes in the input layer based upon the problem. Suppose as I mentioned, to compute efficiency of the transformer, my input nodes will be 3, because one is the output of the transformer, another one is the iron losses, copper losses. Then what? How many output nodes are required? Only efficiency will I want to calculate. Only one output is sufficient. Therefore, this input and output nodes based upon the problems. How many nodes are there in the input layer? how many nodes are there in the output layer based upon the problem. Whereas in case of hidden layer, based upon one of the very popular algorithm, what it says, back propagation algorithm, my hidden layer nodes, because there is no hardened, there is no mathematical rule base, therefore number of hidden layer nodes are approximately equal to 1.5 times the input nodes. Suppose 2 is there, 2 into 1.5 approximately. Slightly more, slightly less also, no problem. But under any such situation, my hidden layer nodes should not be less than the input nodes. Then what happens? It will not learn anything. Okay. Therefore, some inputs are given, it will move from input layer to the hidden layer, and the weights which are there, we will call this the ith layer, this is the jth layer, this is the kth layer, it is the WKJ weights. How many weights are required? 3 into 2, 6 weights are required. What are the weights? This is 1, 2, this is 1, 2, 3. We call W11, okay, W12, W13, 21, W21, W22, W23. Therefore, we can move from input to the hidden, okay, that is, you will get the net, whatever the modeling net you will get, and whatever the function you are using. Suppose you are using sigmoidal activation function, you will get the output O1. Once again, the weights are initialized here. Once again, we will get the outputs like that. The process goes from input to the hidden to the output. And with the supervised learning, as I mentioned, you will require X and Y. If inputs are the corresponding input, the targets also will be required, some T1, T2. Efficiency is there, whatever calculate that will give. Therefore, based upon this one, because weights are initialized, we will go this error, whatever you will get, it will move backward. Like that, while moving backward, the weights are modified. How the weights are modified? The weights are modified like W new equal to your W old plus change in the weight. How will you get this change in the weight expression? This change in the weight expression delta W we will calculate from the learning loss. What is the learning loss? We can see. Therefore, at present, what I am discussing is that the topology will have two types of topologies. One is the feed forward and one feedback or recurrent network. The feed forward neural network is like open loop system. Feedback neural network is like a closed loop system. Yes, it is a feed forward neural network, inputs layer 1, layer 2, etc. and all that. Whereas in case of the feed forward or recurrent neural feedback, okay, this is the feedback neural network, recurrent neural network, the output is fed back to the input. Okay. And one more thing, whatever we are talking about, this is the this neural network. This is how many layers are there? It looks like 3 layers at the layer 1, layer 2, layer 3, but people will call this as a 2-layer network. Why 2-layer network? The input layer will not work anything. Only the process, whatever, suppose it's like a postman, layer 1 will postman. Suppose you will give, my input is X1, the output of the layer 1 will get X1 only. If it is X2, I will get X2 only. It will not do any processing. The processing layers are only layer 2 and layer 3. Therefore, we will call it is a 2-layer network. But sometimes you will have only a input layer and one output layer is there. People will call it as a single layer network. Because only output layer is processing, it is not processing anything. A single layer network. Therefore, in this, with respect to this one, because actually neural network is not new, because people are working in 1940s and all that, at the time they know only a single layer neural network. Therefore, the single layer neural network, the problem was, at the time they know only exclusive problem. What is the exclusive problem? Truth table 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0. Therefore, if I call 0, 0, the output 0 which is there, I will call A0, and 1 which is there, I will call B0, 1 I will call B1, 0 I will call A1 on this 2-dimensional plane. Therefore, A0 inputs are A0, 0, I will call 0 output, and it is 1, 1. X is 1, Y is 1, output is 1. 0, 1, 1 is 0, A1. And whereas B0, okay, X is 0, X is 1, and Y is 0, this is out. Therefore, my problem is this exclusive problem. 2 zeros are there, 2 ones are there. And where I'm only single layer means what is that? You will get only one straight line. Suppose if I will get one straight line, suppose if you see, this is the input XY, weights W1, W2, the weights with small numbers, you can give positive and negative. Net you are getting, and you are using a threshold function. Therefore, threshold, if you keep like this type of threshold, this threshold theta I use some 0.5 like this. Therefore, net equal to xw1 plus yw2. Therefore, it is like a straight line. Then, whenever you are having only one straight line, and you want to separate these 2 zeros and 2 ones separately, I want to do. Therefore, this thick straight line, the green line, if you see xw1 plus yw2 equals some threshold, okay, But changing the slope is now negative. You make it positive or you make it parallel to x-axis, parallel to y-axis. We cannot separate two zeros and two ones. It's highly impossible because you are having only one hyperplane or one straight line or one threshold, one straight line you are having. But by chance, if you're having two straight lines are there, the dotted line, whatever I shown, what happens here when two dotted lines are there, two straight lines, with this one, two zeros are coming within the fold, and outside the fold, what happens is that outside of these two straight lines, I'm getting ones. Therefore, I'm separating two zeros and two ones like this. Therefore, to get two straight lines, what we are do? Suppose when we are having only one straight line is there, we cannot separate zeros and ones. It is known as the linear separability problem. The linear separability problem will take place in the single layer neural networks. Therefore, how we can overcome? If we want to overcome the linear separability problem, we should add more number of layers. Okay. If you see the first point, the serious representational limitation of single layer neural network could be overcome by adding more layers. By adding more layers, what happens? More straight lines are coming in picture. More in the hidden, you have to include hidden layer 1, hidden layer 2, like that. Then more accuracy also increases. Therefore, to overcome the linear separability problem means we have to add more layers, then we can overcome this type of problem. For example, two-layer networks may be formed by cascading two single-layer networks. This can perform more general classifications, separating those points that are contained in convex open or closed regions. Okay, this convex and concave problems are particular optimization, nothing to do with respect to this one. Therefore, here, what this PPT, what I want to convey is that to overcome the linear problems, we can add more number of hidden layers. Therefore, we can overcome this type of issue problem. Okay, if you see the characters of the ANNs are mostly biologically inspired, and the topology may or may not be related to the brain, because in future we may have the difference of the modeling of the topology. Okay, just like what you are considering 20 feed forward and feedback and all that, it may be different also. Therefore, the ANNs are organized in a way that may or may not be related to anatomy of the brain. That if you intersect the brain, it may or may not be related to that whatever you are considering. Okay, general learn from experience and generalize the from previous example to the new ones. And one more important thing is that abstract. What is the abstract? If you read any paper, we will have the first title of the paper. Okay, then author's name will be there. Then abstract will be there. What is the abstract? If you read the abstract, you will get entire summary of that particular paper. Then for abstract, essential characteristics from inputs containing irrelevant data. Suppose it's some data, suppose as I mentioned, input is, let us say efficient, same thing I've been considering, efficiency of transformer, output of the transformer, iron losses, copper losses. Apart from these three, suppose if you give iron losses, copper losses as output of the transformer, along with these three are sufficient. But suppose if you give irrelevant information like resistance referred to HV winding, reactance referred to HV winding also, it is irrelevant, it is sufficient. Therefore, even if you give some irrelevant information, it will not consider that way. That's why abstract essential characteristics from inputs containing irrelevant data. It will not consider this irrelevant data. It will consider only with relevant data. It will proceed. Okay, this last one is not required. And as I mentioned, there are hundreds of parallel series in the neural networks like backpropagation algorithm, self-organizing map, okay, as well as the radial basis function, okay, several things. Therefore, all these algorithms based on these learning laws. These learning laws are the heart of the system. As I mentioned, that is when we want to change the weights, that is W nu equal to W old plus change in the weight. The change in the weight expression we will get from this learning laws. Suppose if you take, for example, supervised learning. The supervised learning, there are different types of learning laws are there. Unsupervised learning, we're having two different types of learning laws are there. Okay, I'm not concentrating on this reinforcement learning. Okay, then what it will do, I want to say, first of all, supervised learning. As I mentioned, supervised learning is I will require input corresponding target Y is also required. The label, okay, labeling. The input corresponding output is also there. We will call target output or desirable output, something we will call. Therefore, corresponding this input, this is my desired output, X and Y. It is if the efficiency of the transformer is there, sub inputs, okay, iron losses, copper losses, as well as the output of the transformer. Here, this is the efficiency. Therefore, this neural network, assuming it is feed forward, the weights we can change. What is weight? Where weights will come? The weights are coming into picture in this in between. That is the weights, layer 1 to layer 2. What is this weight? 2 here input 3 and 2 are there. Therefore, you will have the 6 weights are required like that. Here 3 into 2, once again 6 weights like that. Therefore, the weights, we have to initialize the weights, and I will get the output. A corresponding actual output and desired output. Some error will be there. Therefore, in the supervised learning, error corrects the weights. Therefore, based upon the error, we can modify these weights by using this expression W equal W whole plus delta W. This delta W will get from the supervised learning. That I will talk later. Unsupervised learning, there is only input X is given, there is no Y is not there here. Therefore, it will form into groups, clusters, groups. For example, I will give a simple example. Suppose if the BTech students are there first day of their BTech. In the class when 60 students are there, let us assume they don't know each other. X don't know Y, don't know Z and all that. Then in the first day, the first morning session is over, all students, one will go to north, one will go to south and all that. But if you observe of 10 days or 1 week, what happens? Students will form in groups. 3 will become one group, 10 become one group, 5 become one group. Like how they form the group? Where the teacher is saying that you have to 3 become good friends, 10 become good friends. No. Suppose student has gone to library, he might have seen his friend in the library. They become good friends because friend means all 100% qualities need not match. One is sufficient to have the friend. Therefore, if you have seen the library, therefore you want to make friendship with him because now and then he can come to the library for reading and all that. Suppose someone has gone to Dhaba, he has seen his friend. Therefore, he will become good friend both. What is the common now and then Saturday, Sunday when holidays are there, they will come for a while. Dhabas or hotels they can go. Someone had seen his friend in the movie, in the theaters, they will become good friends. Therefore, the clusters, the grouping is based upon the similarity. Therefore, here also, in the unsupervised learning algorithm, when data is there, I want to make the load 3 different types, all working days, all that group is different. Weekends, Saturday, Sunday, that load I want to make it different, and festivals I want to make because my load consumption is different. Therefore, when I'm having 365 days load data is there, this 365 load data I can make into 3 groups or 4 groups or whatever you want. Therefore, this unsupervised learning, it is used for the classification problem because it meets into similarities of the data. Therefore, will make for the classification problem. As in today, in the deep learning point of view, people are using this reinforcement learning. Okay, whatever you're talking, this supervised learning, unsupervised learning, reinforcement learning, they're valid in case everywhere. They're valid in the machine learning also, in the deep learning also. Okay. Then superficially, what I want to say is that this reinforcement learning, it is if you see the supervised learning, both look same. But where is the difference is that instead of D, where I'm R. R means here reinforcement signal. Suppose we are training the network, okay, instead of giving exact desired output here, I will give supervised learning. Here, some erroneous information I will get. That means, suppose the efficiency is 0.98, let us say. I will give instead of 0.98, I will make it at 0.8, I will give as the information. Even then, information is critical information I given as a like a reinforcement signal I'm calling in place of desired output with respect to supervised learning, even though my network will give me correct output. Okay. Therefore, most of the time we will use this supervised learning, unsupervised learning, and reinforcement signals as in we are using in the deep learning point of view. If you see this reinforcement learning, this learning process is similar to the supervised learning. In the case of supervised learning, the correct target output values are known. Correct target output values are known for each input pattern. And one more thing, the word we will use here, pattern. What the pattern is? Data input and corresponding output. Target output we will call as a pattern. Okay, because every subject will have its own jargon. Therefore, the jargon is here. The neural networks we will use as a patterns. Patterns are data or samples, whatever the maybe. But most of the time, people use the word the pattern. But in some cases, less information may be available. For example, the network might be told that its actual output is only 50% correct. Suppose, as I mentioned, its value 1 is there, I will give target output only 0.5, 50%. Also, thus here only critical information is available, not the exact information. Okay. Is unsupervised, as I mentioned, this is based upon the clustering. The clustering technique is very useful for the pattern classification problems. Then in supervised learning, there are different types of methods. Different methods are there. Five different methods I mentioned here: perceptron learning, delta learning, bit-off learning, correlation learning, outstar learning. Unsupervised, we are on Hebbian learning and computative learning. Okay. Therefore, in this one, briefly I will talk. In the perceptron learning, we will talk in the In the perceptron learning, we will not use any activation function. Okay, anything is there. Our basic objective is I want to compute change in the weight expression. Is it delta low, delta run rule? We will use any continuous activation function like your sigmoidal activation function or tan hyperbolic function. Because why you are using continuous activation function, the delta rule is that we require, that is, if if a differentiate should exist. Suppose when you are having this linear activation function, it becomes zero. If a differentiate will not exist, then to exist differentiation, we will take a continuous activation function. Okay, there is a derivation is there for the delta wij. We can refer any textbook how we are getting. And withdrawal of learning, there is no activation function. Okay, no, without any activation function. Therefore, whatever the net is there, the W transpose of X, I will get same thing. It is nothing but in the supervised error corrects the weights. Error corrects the weights. Okay, the error will get when in case of supervised learning. When you rank supervisor, that is the target is there. Okay, like that, any learning algorithm, our basic objective is to calculate the change in the weight expression delta. If I know the change in the weight expression, able to calculate eta is the learning rate. Okay, always eta is greater than 0 and less than 1, and x is the input, and w is the weights, and x is the input, like that. Then in case of unsupervised learning, the very popular one is the competitive learning. We will use in the one of the algorithm for the classification SOM, self-organizing map algorithm. In this one, suppose inputs are 3, outputs are 3. Okay. Suppose your number of patterns, number of data sets you are having, 10 data sets are there. These 10 data sets, okay, I want to make 3 groups. Suppose I want to make 3 groups based upon mostly we will use some Euclidean distance as well as the what we will do k-means clustering algorithm. Several methods are there. Therefore, in this one, what we will do is that suppose the corresponding input is given, whether it will go to the 1, 2, or 3 to decide. Suppose what we will do is we will calculate the net. What is the net? Net is nothing but your W transpose of X, what you have seen in case of neural network modeling. That is, if suppose this is the net, what is the net? Your input, the weights are there in corresponding xj, corresponding weight is there. Weight is 0 means there is no correction at all. Therefore, based upon this, where I mean 3 nodes are there, I will get this is your net 1, this is your net 2, or net input. Okay, this is a net input of 3. There, as you have seen, x1 w1 plus x2 w2 plus dot dot xn wn. Okay, like that for 3 nodes I will calculate. Then whichever is the highest, I will get maximum value of the W transpose of X. I will declare that is a winner because the name itself competition. In like a game. Okay, whichever is a winner, there is only one winner. So whichever is the highest one, I will make it as winner. And after making it a winner, I will modify the weights only, corresponding winner weights only, I will modify. Some field for supervised learning, we will the different way of modification weights will be there, that I will talk. Whereas in case of unsupervised learning, only winner weights will be modified. Whereas in case of supervised learning, all the weights will modify. Suppose you have 3 into 3, 9. All the 9 weights will modify in case of supervised learning. Unsupervised, only winner weights will be modified. Therefore, here also as I mentioned, any learning law is there, will compute the change in the weight expression. Whereas change the weight expression for this competitive learning or unsupervised learning, one of the learning is competitive learning. You will use this is the formula eta into x minus wm, where eta is the learning rate, eta is greater than 0 and less than 1, and x is the input is a vector, and wm is the winning neuron weights. This is the one of the competitive unsupervised learning. Hebbian learning is also there, but most of the time we will not use Hebbian learning. That competitive learning is very, very popular. Anyhow, this Hebbian academic interest, where I mean 2 neurons are there, neuron I, neuron J. Input connection is Wij. O out I is the output of the neuron I. Out J is the output of the neuron J. Therefore, changing the weight expression is eta into out I into out J. Okay, what is the output you are getting here? What output you are multiplication? This is the change the weight expression. Okay. Therefore, for updating the weights, as I mentioned, W equal W plus change in the weight. Therefore, this one you are getting from the learning loss. Okay. Therefore, so far this indicates learning loss is the heart of the system. Then we can study, we can discuss in some paradigm. Therefore, what is the requirement of the learning loss? Briefly, if we talk, learning corresponds parameter change. What parameter is changing? Your weights are changing. What are the weights? Weights are nothing but small numbers. Therefore, learning law should lead to convergence of the weights. The weights, because we are talking with initial weights, with several iterations and all that, my weights should converge. That is the type of learning law you should select. The learning or training time for capturing the pattern information from samples or patterns, both are same. From samples should be as small as possible. That is, most of the time in the neural when we are having training and testing is there, most of training is offline, testing is online. The training is offline means sometimes good old days when you are doing in 90s, okay, computer speed is less as well as the memory is also very less. To train the large data is there to train the network. Good old days you used to take one day, 24 hours or more than 24 hours sometimes. Suppose in between some power cuts are there, once again we should start from the beginning to train the network. So as in today, to train the network, it will take very hardly some 10-15 minutes. It will not take more than that because the process speed, memory is largely high, very large. It is increased. Therefore, we need not worry as on today. Then whatever the training time it may be, the training time we will not consider. Training time will not consider. Only testing time will be considered in the neural network. In the beginning, as I mentioned, why we are using neural network? My objective is to reduce the computational time, basically. Therefore, in the training, as I mentioned, suppose one of the algorithm back propagation is there. Suppose this is the your neural network input layer, hidden layer, and all that. Okay, we will move from input to the hidden to the output. Okay, your targets will be there. Error based upon the error, I will go back output. Like that, I will modify the weights. Okay, here I will compute, change the weight expression here, change the weight expression here. One iteration is over. Once again, I will present the all inputs. Once again, you will modify like that. Therefore, it is a time-consuming process, training. Therefore, training time will take whatever the time will not bother. But at the time of testing, what we are doing is that in the neural network, my weights are stabilized. The training at the time of training is over means my weights are stabilized from one neuron to another to whatever the connections are there. Therefore, at the time of testing, what we will do is that we will give only input only will be specified. We will know the input. Okay, that network give the output I will get because weights are stabilized because initially in the training that we have considered random weights or initial weights we have considered. Therefore, at the time of training, what is happening is that the weights are capturing the pattern information. That's why after thousands of iterations, network will be stabilized. Network is stabilized means even if you increase some more iterations, okay, weights will not change. Weights are nothing but small numbers between one neuron to another neuron. At the time of testing, what we are doing, some input is given, a novel input, which is not a part of the training. You should give a input. We will not give any output, even if the supervised learning. It will give the correct output. Output you should calculate. Whatever the neural network will calculate the output, and in my hand, whatever the output is there, both should match. Then testing is over. I want to talk one more thing with respect to training and testing. Suppose a kid is admitted to understand the basically what is the training and testing. Suppose a kid is admitted in a school, his age is less than 3 years or slightly more than 3 years, etc. Suppose a kid don't know how to write A. In the first day of the class, what teacher will do on a paper and pencil, you'll write A, capital A, let us say. The kid don't know how to write. You'll take his hand, write this line, this line, this line, several times he will repeat. When you're repeating several times, he understood, oh, if you write this like this, line 1, line 2, and in between, it will become A, capital A. Therefore, the kid, if you already repeated several times, he might have written thousands of times, he has repeated on that A. Then after one day, okay, if the kid IQ levels are very high, within one day that fellow can learn that capital letter. The student is average, within it will 2 days or 3 days it will take. That means, what I want to say is that if you want to learn anything, we are repeating several times. A, then B, then repeating several times. It is also shown we have shown several times that letter or this data to the network. Okay. Then every day, let us say for all the entire after 2 months or 3 months in the school, all students have learned A, let us say. Then you know, teacher want to conduct exam. Exam means the teacher will not ask write A to B, A to Z. A to Z means if you write A pattern, as I mentioned, associative memory, you can write B. If you know the B, C. But teacher want to conduct some dictation. Write P, write Q, write Z. Therefore, you should know the capture, how the P looks like, how the D looks like. Then only student can able to write. Okay. Therefore, this is like a testing. And one more thing, it is training is like one more example. Let us say I'm watching a TV. Then I'm watching a TV in a serial. Okay, daily the serial comes at about 8:30 p.m. Therefore, as you will know, the serials will be they are prolonging up to 1 year also. Therefore, I'm watching that serial since last 3 months. Therefore, when serial is going on, after serial 5 minutes or 10 minutes, serial is over. Then some advertisements will come. What is the advertisement? My Sony TV. It says that Sony's best is a Sony TV. After some time, it says that LG TV comes in, for example. The LG TV is only LG washing machine is only best like that. Therefore, I'm watching since last 3 months. The which is the best TV means Sony TV is the best. Suppose after some time my TV is giving some problem, I want to purchase a new TV. I will go to a shop. Except Sony TV will shows all the TVs, LG TV shows as well as the Panasonic TVs, like several things. Then we are not happy because already my brain is trained. What is it which has trained my brain? Already is biased by train. So TV is best TV, Sony TV is the best. Suppose if the shop is not available, I will go to another shop and I will purchase the Sony TV only. Because only which is the best TV is Sony TV. Because bias trained by network, by biological neural network is trained, the best TV is Sony TV only like that. Therefore, this objective of the learning is that objective of any learning law is that it should eventually lead to a set of weights which will capture the pattern information in the training set data. Therefore, what is the time of training? Several times you're showing the data means what is happening is that it is capturing the pattern information in terms of weights. Okay, we can use for several applications, supervised training, supervised learning. Okay, and we can use for different problems: pattern recognition, pattern classification, function approximation, optimization, prediction, automatic control, and whatever. Then one of the popular algorithms is the backpropagation algorithm. In the backpropagation algorithm, it is very simple actually to understand, and I will most of the time in the class I will ask the students to do their own hands. Accuracy is not an issue, but how the information will process like that. Suppose, as I mentioned, in this backpropagation algorithm, it is a feed-forward algorithm, and it is a feed-forward neural network. Input layer, hidden layer, output layer will be there, and it is supervised learning. The supervised learning, it will use delta rule. It will use delta rule. We have used in the supervised several things. What is that? Withdraw off, okay, as well as the perceptron learning, several things. Here we will use withdraw delta rule. We will use. It requires a continuous activation function, and the optimization techniques what you are used for this to compute this delta J, delta Wij, and all that. We will use steepest descent learning method. Steepest descent learning method. Optimization. Okay. Therefore, in this one, okay, as you will know, you were having toolboxes. The MATLAB also is there. But before using toolbox, what I will say is that how it works. For simple problem, we can. But to compute efficiency of transformer, neural network is not required. But just if you do how it solved, we can able how the process is going on. Then you can use any toolboxes and any software you can use for the applications. Therefore, the algorithm is very simple. And the name is back propagation. What propagating backward? Suppose my input, my network is like a neural network. All are interconnected. Okay, my input is some small x1, some x2, is a capital X1 vector, and corresponding target desired output is some D1, let us say. Therefore, weights are is the ith layer, this is the jth layer, this is the kth layer, this is the WJI, this is WKJ, I will call 3 into 2, 6 weights, 1 into 4, 4 weights I will initialize. As I mentioned here, we will have the activation function, okay, some nonlinear activation function. We will move from input to the hidden to the output. Here, output you are getting some. This is OK, this is the decay. Error will be there. Based upon the error, we will go backward. While going backward from kth layer to jth layer, I will modify the weights. Okay, to modify the weights, this is the expression. Okay, this you can use any textbooks, any paper. Okay, again from hidden layer to output, you will modify these weights. Okay, once again, weights are updated. Now I will give another input, that is x2, corresponding D2. Once again, I will move forward, backward like that. Therefore, this is about the update the weights. Okay. Then we will repeat the steps 3 to 5 until all parameters in the training set have been considered, all the patterns, number of patterns. Because one more thing in the neural network is that more data, more accuracy. More data, more accuracy. Because we will have, suppose if you take 1,000 patterns, 100 patterns, let us say, for example. Out of this 100 patterns, for example, if you take 1,000, much better. In this one, what we will do is that, and these patterns should be generated randomly. Linearly, one should not generate. What is the linearly? I will explain later. Therefore, when you are having 100 patterns are there, out of these 100 patterns, 70% used for the training of the network. Remaining 30% of the data used for the testing. Why we are using for 30%? Because to make whether I want to check whether my network is more robust or not. That's why 30% of the data we are not checking. We are not checking with only one data or two data. And seventh point, if you see, compute the error for the present iteration. Okay, then we'll take instead of there are two ways. One is every pattern we can modify the weights. Okay, another way is that for the pattern one is the error E1. Don't modify the weights. Error E2 only go forward direction. And error E2 like that 170 patterns are there. You will get E1 plus E2 plus E2, E70. Let's say. But if you take algebraic summation, what happens is that some errors are positive, some errors are negative. My error may become zero probability. Therefore, to avoid this one, what people will do is that they will take sum of the square of the errors. To take the sum of the square of the errors, error never becomes zero. Error is not become zero, our algorithm never fails. That is one of the objective. Therefore, error take the sum of the square of the errors. Then after that, taking the then we can modify the weights from output layer to the hidden layer to the input layer like that. When error is small, then what we will do is that we'll stop training. That is, my weights are stabilized. Present error and previous error should be less than or equal to some epsilon, 0.301 or 401. Okay, then we'll stop the training. When training is over, means my network has learned the weights. Like that. Therefore, the testing. Therefore, before proceeding this some other thing and all that, just I want to talk about. General with respect to supervised learning point of view, I'm talking this with respect to supervised learning, how to solve a problem or how to attack a problem, a general way. Then, as I mentioned from the beginning, training will be the testing. Two things are there in the neural network. Therefore, the first thing is, suppose you come back to this training, the first thing is that generate the training patterns. If you know how to generate the patterns, then 50% of the problem is solved, because that is the most crucial point with respect to the neural network. For example, suppose you have my transformer. I will give simple example. Transformer, this rating is 3 kVA. Let's say 3 kVA. Assuming my power factor is 1. Okay, for example, and iron losses, let us say assume 50 watts, and my copper losses, let us assume some 60 watts, for example. Full load, let us say. This is only one set of the data. Like this, I want to generate 100. How can you do? Then what we have to do is that when this 3 kVA is there, that is 3 kVA means your 3000 watts, my power factor is 1. Okay, this is the maximum highest. Minimum I will make a 10 latest 10 watts output of the transformer. Between 10 and 3000, you use a rand function in the C program, rand. Okay, minimum to generate random numbers. You require what is the requirement? Minimum value you require, maximum value you require, and one more thing is how many you want. You want only 100 numbers you want, 1000 numbers you want, you have to decide. Suppose let us say I want 100 numbers. Therefore, I should mention now how many numbers between 10 and 3000 is 100 I require. Therefore, 100 numbers I will get between 10 and 3000 randomly I can generate. Therefore, after generating randomly, then what we will do, we are having for each 1 to 100 outputs are there. Each one, your iron losses are constant. What copper losses will do? Copper losses are not constant. They will vary with respect to the load. Okay, transformer output. Therefore, each one I can calculate the copper losses. Here, iron losses are constant. I can keep. When these three are there, output of the transformer, iron losses, copper losses. Therefore, I can calculate the efficiency. Therefore, efficiency of the Vishlasam formula, output by output plus losses. So each one I will calculate. Like that for 100 patterns, 100 data sets I calculated, input corresponding my desired output. Therefore, as I mentioned, 1 to 70 I should give for the training, 71 to 100 of 30 patterns which are there for the testing. Therefore, to generate the patterns will play a vital role. Okay. And most of the time, second point, if you see in electrical engineering, we will have the voltage, kilovolts, watts, and megawatts will be there. Large numbers are there. Kilovolts, megawatts we will talk. Therefore, whereas weights are small numbers. Therefore, when your large numbers are there, our data, it cannot train, it cannot learn. Therefore, we have to normalize the patterns. Therefore, the entire data which are there, 100 data sets are there, you pick which is the minimum, which is the maximum value. Then I want to keep within the range 0.8 and 0.1 within that. Okay, there are several formulas are there. We are using this formula. I want to keep whatever the data in the range 0.8 to 0.9, or you can keep 0.9, just make it 0.2, your choice. After normalizing the patterns, then initialize the weights. Okay, as I mentioned, why you want initial? One more question will be there. Initializing the weights, why will be only between greater than 0 and less than 1? Thing is that suppose whenever you are using a sigmoidal activation function, the sigmoidal activation function will go to plus infinity. When it will go to plus 1, it will go to plus infinity. When it will go to 0 exactly, when the function goes to minus infinity. Therefore, plus infinity and minus infinity, physically there is no meaning at all. That is why what we can do is that greater than 0 and less than 1. Therefore, between we want plus and minus 0.2, plus and minus 0.25. Like that, we will generate the initialize the weights. Then, based upon the paradigm, what algorithm, whatever you are using, select a suitable non-linear function, whether it is a continuous activation function or a discontinuous activation function, linear activation function, or you can take a non-linear activation function based upon the problem. Therefore, fifth point, okay, map the input-output pattern. Where input supervised learning point of I'm talking, as I mentioned, input correspond output is that just what we are doing. So you talk about back propagation algorithm or some other algorithm. We are mapping, okay, input-output patterns according to the specified algorithm, okay, based upon the thing, whether it may be BPA or maybe RBF, radial-based function, etc. When error becomes small, stop training. This is how you are training it up. A simple general way of talking about. Then every training is over, our learning is over, my weights are stabilized. Then what we are doing is that testing. Test the neural network with novel input pattern. Novel means you have used a new input pattern. That suppose you have used 1 to 70, same thing you should not use 1 to 70 for testing, because same thing you have given, okay, it will give 100% accuracy. You should give novel, because 71 to 100, whatever it is there, you have to give. The training and testing, one more example I will give. Suppose a teacher is doing a problem in the class. Suppose to determine efficiency of the transformer or torque of torque of a DC motor, etc. Whatever. And here, when teacher has done the training point of view, talk about torque of an equation is doing. The parameters which are required is changing. Suppose when you have taken 10 minutes, another time you take 5, another time, another you take 6. Like that, you change the thing. Everything. Training is over. That is, teach the same problem. Just by changing the numerical, teacher has done some 5 times exercise. In the examination, same problem is given, but other than the 5 times teacher is used, other than those numericals, teacher will give another set of the data in the exam. But problem is same, to calculate the torque of an equation, torque of a DC motor. Therefore, is it possible to do? Everyone can do, because already 5 times you have done the same problem with different numericals. In the examination, same problem, but another, not 5 same, whatever teacher has done in the class, other than those numericals he has used in the examination, that is what we call a testing. That's why test the neural network with the new input pattern. Therefore, students should be able to do. Therefore, network will do definitely. That's why the training and testing, this will play a vital role. Therefore, one more thing with respect to the this is I took an example for a general thing. Suppose if we talk about this power system, suppose if you say, I will give simple example, some load flow point of view. Suppose in this one, suppose if you take a 3-bus system. Okay, this is my bus number 1, bus number 2, bus number 3. Okay, the load flow analysis point of view, we will call 3 different steps. The buses will call that one is the slack bus and PV bus as well as the PQ bus, etc. But here for simplicity, I took bus 1 as a slack, or the slack bus is the must. Without that, we cannot proceed. And bus 2, bus 3 as the load buses or PQ buses. Then with the PQ, they will mention what they will mention. Some the P2 plus JQ2 is there. The values. This is some 0.5. This is like 1.0. P3 Q3 they will mention, let us say some 3 plus J2, something like that. Because in to solve the problem like load flow analysis in power system, okay, then most of the time we will assume my generation is constant. For generator is generating 500 megawatts or 100 megawatts, okay, it's constant, fixed. But where it changes with respect to in a scenario, our load will changes. How the load changes? Load will become 0? No. But load will changes based upon the time pattern and all that. We therefore will assume my load will change approximately from 80% to 120%, assuming load is changing. Then what we are doing is that when in case of the load flow, you will have both. Suppose if you take your load flow, what is the input to the load flow? You require line data as well as the bus data. Bus data means what at the bus, what is happening? We are having load only. Okay, sometimes we have a generator also. Therefore, we will take net injections. PI, QI. What is the PI? It is nothing but your PGI minus PDI. Where QI is nothing but your QGI minus QDI injection. Here generation is always fixed, even if the generator is there, for example, and demand is goes on changes. Then first thing is that what is the output? It is the output of the load for the state vector. What state vector means? Each and every bus I want to compute voltage magnitude and phase angle. That is your V2 delta 2 as well as the V3 delta 2. And as you will know, slack bus is there. Whereas this V3 and delta, sorry, V1 and delta 1, the values we will provide the values for slack bus. Except slack bus, other buses we have to calculate the state vector. There is voltage magnitude phase angle we have to calculate. Therefore, if you want to make use of this type of problem, you can attack by using a Newton-Raphson method or Gauss method or Gaussian method. But if you want to solve by using neural network to reduce the computational time, that is my basic objective, then what you have to do, you have to generate the patterns. That's the first step in the training. Then how to generate? Suppose 100 sets of data means, whatever the data you just provided in the textbooks and all that, you can get only one step, one pattern only will get, one input. And one more thing, for any problem, how to give the inputs of neural network. There are several ways. For the load flow, what we use, suppose here in case of the 3-bus system, slack bus, there is no need to calculate. Therefore, for these 2 buses, I will give P2 injection and Q2 and P3 and Q3. Then what is the output I will get? I will calculate the voltage. Slack bus I need not calculate, only at bus 2 and bus 3. Therefore, this is your V2, this is your delta 2, this is your V3 magnitude, and this is your delta 3. And this you will get a hidden layer. Therefore, as I mentioned, the input layer and hidden layer nodes are correspond based upon the problem, which problem you are attacking. Where 3-bus system, this is fine. You go for 10-bus system, some other thing will, number of nodes will increase. Therefore, then what we will do is that the first thing is that to generate the patterns, what to do? There is a question. Therefore, what as generation is fixed, load is goes on changing. Line data means actually line data is required to run the load flow. Therefore, we have to form the Y bus, etc., and all of those things. Therefore, with respect to injections point of view, I should generate some 3 is there. This 3 at bus number real power, this is the P3, okay, or PD3 I will call demand at the bus 3. Therefore, this 3 is there. 3, what I will do is that 3 I will multiply with 0.8, that is 0.24, and this 3 I will multiply with 1.2. That is how much you will get? 3.6. This is the minimum value, this is the maximum value. Between minimum value and maximum value, we can get 100 data sets by using random number. Correspondingly, you can modify Q3. This also can change between the limits 80% to 120%. Wherever the load is there, you can modify all the loads between 80% to 120%, minimum value, maximum value. If you want set 100 data sets, 100 times, 100 values you can get. After that, what you will do is that if generation is fixed, therefore generation minus demand, that is your injection you will get. Each bus you can get the injections. Your injections are the input and desired outputs are your voltages, corresponding voltage of 100 times you have to run the load flow to get 100 sets. Out of this 100 sets, 70% of the data I will give for the training, okay, and remaining 30% I will give for the testing. Therefore, when you are given this is the input, okay, I will target output. Then what you will do? Error, I will go back, forward input to the hidden to the output, okay. Then I will go for error is there, the error I will go backward. While going backward, I will modify the weights by using the expression change the weight x from W, AJ, some formula is there. Similarly, while moving from hidden layer to the input layer, W, JI, I should get the expression. From this expression, I can modify these weights. Like that, we will go on change the weights. Therefore, this is about the thing with respect to one of the problem, how to solve a problem or how to attack a problem by using for the power system problem. Therefore, like this, we can use for anything. And one more thing is that sometimes what happens is that my network will not converge. If not converging, what we are doing is that suppose you have taken initial weights between plus and minus 0.5, you modify, you make it plus or minus 0.1, let us say. And sometimes eta you might have fixed as 0.6, okay, eta you make it to reduce 0.2, 0.3. Because what happens is that this neural network point, this backpropagation algorithm in point of this one, sometimes because the algorithm is based upon the steepest descent method, it may stuck up in the local optima. Suppose this is the x, okay, this is the f of x, okay, some error or whatever. These are all your local minima. This is L1, this is L2, this is the some minima, this is L3, okay, this is L4 minimas. Because optimization means it can be minimization or maximization. These are maximas. Okay, I'm talking about minimas. There are several minimas. Are there 1, 2, 3, 4, 5, 6? Okay, out of all minimas, this is the highest one. We will call this as global optima or global minima. Global optima we will call. Sometimes what happens is that the problem, the weights which are modifying every time, they will go and stuck up in somewhere here, local optima. The stuck up here means you will get in the, how we can notice this one. My network has stuck up in the local optima. You are at the time of testing, you will notice. Or at the time of training also sometimes you will know. Because whatever the weight change, it will sometimes it will not change, or all values will be same, something like it will stuck up, or weight will not change at all sometimes, several ways. Therefore, when this type of problems are there, some practical issues, then you have to take care of by changing the learning vector, eta, and change by means of weights. And one more thing, learning vector. As I mentioned with the learning rate or learning rate eta, as I mentioned, it should be greater than 0 and less than 1. Greater than 1 means I can go up to 0.95 or 0.99. I can go. 0 means near greater than 0 means I can 0.001 also I can go. Suppose if you take very small value, the training will take more time. Training will take more time. Therefore, but it can, if eta is very, very small, we can overcome this type of local optima problem. Weights will stuck here, this type of problem. Slowly it will move and all that, it will come and settle down in the global optima. But whenever you are using large value like 0.95, 0.95, 0.8, like that, what happens is that it's moving very fast. Just like you're running driving the vehicle. Suppose you are moving your two-wheeler at 100 kilometers per hour. It's fine if there is no problem. But suddenly someone has come in between to stop it. It is very difficult. It is out. Okay, it will become accident. But when you are moving very slow, let us say 40 kilometers per hour, 50 kilometers per hour, there is no possibility for accident. Anyone come in between of any obstacle is there, immediately I can brake, I can apply so that type of problem will be there with respect to when you use small, it is always best. Okay, if large values, may stuck up some local optimum problem. Okay, this type of things will be there in there, and like this, several hundreds of algorithms are there. Okay, therefore, if I have any questions, I will try to answer. Any questions are there? And most of the time, as I mentioned in the beginning itself, how it works for the beginners point of view. Those are having some already worked, well and good. But beginners to learn is very, very simple. Only thing is that you should be able to know. That is, you initialize some weights between input to the hidden to the output, and some inputs give how it is moving. Input to the hidden layer to the output. Okay, how it is going backward. If you do your hand calculations, more clarity will come into picture. Otherwise, everything looks like fuzzy. And one more thing is that, as I mentioned, to simple example for transformer. Okay, some in the laboratory, okay, take a transformer of the full load rating. Okay, but the output is something, iron loss is something, copper loss. Based upon that one, try to generate the patterns offline in your sitting in your room. You can do. Then if you do this one, you can understand how it works, and it will create a lot of interest. Otherwise, everything looks like somewhat fuzzy. That is, we cannot understand how it is working. But in the neural network, the simple mathematics will be there compared with the machine learning. In the machine learning, everything a lot of mathematics is required, and you require statistics, probability, optimization techniques, linear algebra. Several things are required there. Here, just the linear algebra and simple optimization techniques are there. That is sufficient. If I have any doubts, I will try to answer. And in this type of subject, if you can pose the question, means one should be able to work. Then a lot of questions you can pose. If you are not working, means we cannot able to pose the questions also at this type of lecture in this. Suppose anyone is working in this area, suppose they are having any someone they might have stuck up somewhere, I can answer. No questions or Bhaumi?
Sir, so if you have any questions, you can ask. Uh, um, Mainly from the participant. So participants are requested if you have any doubt or uh, questions, you can ask to Professor Kumar. So Ujjwal, sure, few minutes back you have raised your hand. So if you have, you can ask. Ujjwal, sure. Okay, sir. Maybe they don't have any questions.
Okay, any question? Just before that, just I will because the time I could not able to
Yes, sir.
complete everything. Just I will come one slide. I will show. Then I will stop. One thing. This is very my favorite proverb. It says, "If you have a hammer in your hand, everything looks like a nail." If you see straightforward, like what is there in this one, it looks like what is the hammer is there, and hammer everything. Just like this, power is based upon. Suppose our sons or daughters they are studying in hostel. In the exam after exams are over, they will come to the house. What mother will do? She will do good food, prepare the good food which they like very much. They will have the taste the good food as well as they will watch TV and all. 3-4 days they will spend like that. Fourth day, let us say in the house, somewhere they might have seen the hammer. What they will do, because there is no work, is it not? They will see the walls, any nail is there. As on today, no nails will be there. Good old days, nails would have been there on the walls and all that. And they, if there are no nails on the walls, they will check the on table when a nail is coming out on table, etc. Sometimes if there is no nail also, we will hammer the table itself. It is a general what it looks like. But strictly speaking, with respect to this artificial intelligence techniques, what is a hammer? Hammer is you're having different techniques like your neural network, some fuzzy logic, some evolution algorithm, some machine learning algorithm. Suppose if you know, okay, when you're reading something, suppose you are doing some research or you're doing for the project work, when you're reading something, some people might attack by using some algorithm. Immediately strikes because already a hammer is there. Hammer means you're having some knowledge about machine learning, neural network, deep learning, something is there. Immediately strikes how to solve this problem by using these methods. What are the hammer in your hand? Therefore, you can hammer it that problem with your whatever the subject, whatever the different algorithms you will know, we can solve. That is what it says. Hammer is the different techniques, and nail is like a problem. That is. Okay, Bhumi. Then I will stop.
Yes. Thank you, sir.
Thank you, sir. Sir, we want to request to sir if they will share PPT in PDF formats, we
Right.
will distribute among the participants.
Yeah, same thing I will. Whatever, if something extra is also there,
Yes.
same thing I will mail
Yes, sir.
Bhumi
So
and
up
Bhumi
to
will.
this, you can consider apart from that the extra slides you can ignore. So make it PDF and send it to me so that
Yes,
we
sir. So we will share among participants. Thank you, sir. Thank you very much, sir.
Okay. Thank you. Thank you. Thank you, Mr. for giving me this opportunity. Thank you.
Thank you, sir, for your informative presentation. That all the participants.
Okay, I'm leaving Bhumi now.
Sir, just 1 minute, sir.
Sir, if you switch on your camera, so we'll
Okay,
take
definitely.
one snap.
Okay, sir.
Okay.
Yes.
So we look forward to having you again in next series of series at NIT Durgapur. So thank you once again from the part of participants, then NIT Durgapur, then organizing team also. So with these few words, we can conclude, and you are requested to say few words before session gets concluded. Thank you, sir. So plus stop sharing the slides, sir, first. Sir, do you want to say something to the participants?
That is why first of all, if you want to, because some people may be interested, some people may not be have any interest. Having some interest, then you can do wonders. You want to do continue in this area. My advice is that most of the time, the class also, what I will say is that do hand calculations, one iteration, because we cannot do whatever computer is doing hundreds of iterations. We cannot do one iteration, how it is doing, how it is working, then we will know each and everything. Otherwise, even most in the machine learning algorithms, some regression or polynomial regression or logistic regression, anything is there, I will ask the students to do some hand calculations. I will ask. Therefore, it will create interest. Neural network is there in the beginning. Suppose you take a feed forward neural network, or okay, feed forward, like open loop system, what I mentioned. They can give, instead, they can have some inputs, some outputs, then they can move from input to the output. They can do some calculation, output hidden layer to the output layer, like that they can do. Therefore, we can do a lot of things, and we can, because most of the time, as in today, we have to publish the papers. Therefore, we want to publish the papers, we have to test with the existing algorithm, as well as the, we should go for hybridization. We have to hybrid, because some algorithms are good in one aspect, another algorithms are good in another aspect. Okay, therefore, if you hybridize and if you test, if that hybrid algorithm is doing much better, okay, we can that is your own contribution. Okay, therefore we can publish papers. Therefore, to understand also, we should have some hand calculation. That is my, that is why I use the word. I will ask the students to do with their own hands. Sometimes students are lazy and they want to check what their friends are doing, that's sufficient. But that is why we use the word. I will ask the students to do with their own hands, like that. Therefore, it is very upcoming and emerging area. Therefore, having interest, and you can do a lot of wonders also you can do. Thank you, Dr. Bob.
So we'll in touch with you for our future reference also. If
Yeah,
you need any help, so you are requested to cooperate with us, sir.
yeah, definitely.
Right.
Okay,
So all
thank you very much.
participants are requested, please turn on your camera so that we can have a snap. Please.
Please, all of you, turn on your camera once.
Okay, sir. Thank you.
Okay, yeah. Thank you, Bobby, for giving me the opportunity. Thank you.
Okay, thank you, sir. So now we are the last